Welcome to yet another Tim Plays Longlife stream. Now, I have a bit of a confession to make, guys. You're probably looking at my stream and you're going like, what? Why do I see Streamlabs? Why am I actually seeing the display of Tim Plays Longlife? And ladies and gentlemen, I'm going to answer that question to you right here and right now. And the reason for this is today we're not going to play a game. No. Today, your boy has a mission, right? Your boy has a mission to complete a programming assignment. So I thought, hey, why, instead of streaming a game, or instead of like not streaming in this case, why don't I put my head down and say, hey, I need to complete a programming assignment. Let's just do it live on stream, man. Number one of the requirements of this assignment per se is that I as an individual cannot use AI during the making of this system, the making of this program. So, wow, we just got a subscriber. What's going on? Welcome to the Longlife Army. Mwah. Join the Discord. We do cool things. Anyway, so like I was saying, we cannot use any AI. It is illegal for this assignment, right? And the reason for that is obviously, if you're going to use AI, you're not using your full potential. You're not learning how to properly program, and any work that you produce, the AI had a hand in it. You don't 100% understand your work, and it just leaves a bit of a rabbit hole, right? So what we're going to do is we're going to go back to basics. We're going to read documentation. That's right, ladies and gentlemen. Today is going to be an unfiltered look as to how you're actually supposed to program, how you're actually supposed to look at a problem, digest whatever it is that the problem that you need to solve, and then you're going to solve it, right? So as a two-parter of why I'm doing this live, number one, I think it's pretty cool to see someone like actually program live, bit of peer programming. I think it might make for an interesting stream. Number two, we're not allowed to use AI, so it doesn't get any more unfiltered than this. This is me literally sitting in front of a camera, sharing my entire screen and programming. So I had to do a little bit of setup today to make sure I don't accidentally like dox myself or like share anything that I'm not supposed to on my stream. So everything is like completely stripped. There's like raw desktop. There's nothing there. Like literally, if I look around, you can see my entire screen here. Like this is paint. This is literally paint, bro. Like actually. So hopefully anyone that's watching here will actually learn something. If there's smart people in chat, you know, you can hoy a question there. I'm not going to accept any help from chat because, yet again, this is the problem that I need to solve in particular. So if you guys just want to stick around for the ride, go for it. If you have any programming questions, I will happily have a crack at answering them. But I'm going to approach this problem as if like this is how you're supposed to approach the problem, like completely from scratch. So I'm going to use stream as a bit of a rubber duck. So any concept that I come across during the course of solving this problem, I will thoroughly research. I'll explain it to you guys so that even if you know nothing about programming, you can at least follow along the stream. And you might even learn something too. So let's get straight into it, straight into the content. This might be a bit of a issue, might be a bit of a problem. But let me jump straight into the problem that we need to solve firstly, and then we can discuss it, then we can get into it, right? So here is the assessment. I did it in such a way that wherever you're looking, you'll be able to read it. Whether you're on the portrait view, which most of you currently are, or if you want the full experience, you can see my entire screen. Just click the little directional thing there on your phone, and then you just turn your phone the other way around, and then you'll get like the entire portrait view, right? The entire normal view. So step number one, get hydration, get some water. this needs to be completed by Wednesday. So I'm literally just going to work on this forever. As much time as I can physically. So let's jump straight into the assessment. First things first. The system that we are working on right here, the system that we're working on is used to make bookings for people going on holiday. This could be apartments, vehicles, show, etc. I'm just going to read it through and then we'll break it down, understand the problem, and then I will literally list step by step how I'm going to break this down. So, vehicle, show, etc. The assumption we work on is that there will always be availability of what needs to be booked. You do not need any persistence to SQL/file, etc. This can be stored in memory or wherever you prefer. You are part of the backend engineering team, and the requirement is for a basic solution that would allow someone to add a booking, edit a booking, or delete a booking. If you can add a unit test or front end to show it is working, it would be great. So let's break this down, ladies and gentlemen. The task that we need to complete, right, is we need to create a POC. This does not stand for a piece of crap, okay? That is not what this abbreviation means, right? POC stands for proof of concepts, a very basic solution that just shows, hey, this is how the technology works, this is how the system works. It's not ready for like a proper deployment, meaning like, hey, a customer is never going to touch this, right? This is purely just to showcase a solution, showcase a train of thought, anything along those lines. So that will be used. So we have to create a POC that will be used to help people that is going on holiday to make bookings. This could be apartments, vehicle shows, etc., as we read in the original assessment scope. The assumption we work on, I listed it nicely in bullet points. The assumption we work on is that there will always be availability of what needs to be booked. So why they made that distinction in particular is, let's say in a normal system, if I wanted to make a booking for a car, there's obviously only going to be a certain number of cars that can be booked, right? So in this particular assessment, we don't need to worry about whether or not there is enough cars, right? We don't need to build out the logic that'll check to see if there's enough cars. We just need to worry about the actual making a booking part, right? So that's number one. Number two, we do not need any persistence to SQL/file, etc. This can be stored in memory or wherever you prefer. So let's break that down. What does it mean to persist? Persistence means, like, let's say I make a booking for a car, I delete the program or I restart the program. When it comes back up, my booking is still there, right? Because normally when you exit a program or whatever, the cache gets deleted and you generally don't have, it's called persistence. So basically when you restart your computer, all your programs that are currently running shut down, and when your computer starts back up again, unless you mess with your startup, when you start your computer back up, those programs aren't there anymore, right? They didn't persist, right? We can get into like like random access memory. You can get into storage another day. For now, I'm just going to focus on the assessment. So that's what it means to persist. So what they mean in this context, the assumption we work on is that they will always, you don't need any persistence to SQL/file. What they mean by this is we don't need to have a fully fledged database. We don't need to have it persist to a file. So when you save something, you can go in two ways, right? The proper way is to put it in a nice database so that it's nice and structured. Everything has an ID. Everyone has whatever. Or you can just like save it in an object and throw it into a file, like a text file or a JSON file. Text files are a little bit metric, but we will digress, right? So for the purposes of this stream, for the purposes of this assessment, we're going to go above and beyond, right? We're actually going to at least attempt to make a proper DB structure just so I can get into the habit of setting up migrations, making sure that that section of my fundamentals is 100%. We do only have 2 days to do it, so if we're gonna do it, we need to sort of be efficient and like do it properly. So we will touch back on that, but basically that's what that bullet point means. We don't need any persistence. This can just be stored like in memory, which is like your local host. So it's gonna have an ID anyway. It's going to be in your memory. We're gonna have to research how to do it regardless. So I have more experience in working with a DP, so that's what we're gonna go with, right? It's whatever you prefer. I prefer working in a DP. Next, you are part of the back-end engineering teams. Now, what does that mean? So in programming, there is certain concepts you need to understand about the life cycle of a program, right? Very, very basic that you learn in school. You have a front end, which is the part that the user can see. So let's say I am making a program, right? There's 2 parts of the program. There's what is stored in the back end, which is like where you do all your calculations, where you're supposed to do your DB calls, where you DB meaning database. So on that previous point where we said like wherever we persist, generally you'll have stuff that's persisting. So in your back end, where I will literally say, hey, database, I need something from you, right? You're not going to make that call from the front end, right? If you do, bad practice. Don't do that. But anyway, the distinction is front end is the part of the program that the user can see. So that's where you are going to style your buttons, make sure the layout of your application or web application in this instance is nice. You're going to make sure that there's beautiful colors. When you click this button or when you click this button on the front end, it does this or it triggers a back end call. That's generally what you do on the front end, and back end makes the front end work. Long story short, right? Then you've actually got a whole bunch of other things, like you got your DevOps that like manage infrastructure stuff. That's like later programming. Like 2 or 3 years into your programming career that you'll encounter that stuff. I do have experience in that. I've done Azure, I've got my AWS certification, so I'm well versed in that. But for the purposes of this session, purposes of this stream, I'm gonna assume most of you do not program. So I'm gonna break this down in hopefully a way that you guys can understand. So all you guys need to understand for this, what is the back end? It is code that makes the front end work, or when I click a button on the front end, what does it do? The what does it do part is handled by the back end. What is the front end? It is actually making the button that color. Daniel van Tonder, how are you doing? Welcome to the stream. We are programming today, and I'm breaking down a programming assessment for you guys so you guys can understand. I need to do it for an assessment, so instead of doing it alone in a dark room, I'm going to do it alone in a dark room, but on stream. So let's get cracking. We are here. So we're part of the backend engineering team. The requirement is for a basic solution. So a basic solution ties into the sentence I said, yeah? When you create a POC, a proof of concept, very basic, doesn't need to have all the bells and whistles, just needs to show that we know what we are doing, right? We need to create a basic solution that'll help someone add a booking, edit a booking, and delete a booking. Those are the 3 like important things, right? Now, what does that mean? That falls under a concept known as CRUD. C-R-U-D. I'm going to edit here at the bottom. C-R-U-D. What does CRUD stand for? Create, read, update, delete. Now, these are just words to me. What does it mean? So, a little bit earlier, when we were talking about persistence, right? Persistence, when you say the word persistence, you're automatically thinking of something that can exist beyond the current instance of whatever you're working, right? It continues after you shut it down. Generally, the way we go about that is we have some sort of way to save whatever you're working on, right? And when you save something, that gets saved in a database. Data, lots of data, in a base, etc. So, what is CRUD? Well, when you have a database, you need a way to interact with that database as a programmer, and we call that CRUD. When you create something in a database, we are adding something to the database. When we are reading something from a database, we're saying, hey, database, I need something from you. Can I have it? That is, we are reading, right? Updating a database implies that, hey, I already have something in you, right? So let's say I have a name, right? My name is Timotheus, or Tim Plays Longlife. I create a profile. I say my username is Timothy, right? But I want my username to now say Tim Plays Longlife. So when I change it, I am updating my existing profile, and I'm changing it to Tim Plays Longlife. So I'm updating it, right? So that's create, read, update, done. Delete. Hi, boy. If you don't know what delete is, come on, guys. Here's a Google. Delete means you are taking it away. But just so you know, bad practice. You do not delete something directly in your database, right? Generally, you will archive it, which means you're not deleting it. You're just changing. You're just putting it away in deep storage, right? Because let's say you work at a fintech company or a bank or whatever, right? Let's say no, fintech's a bad example. What's a good example? Let's say you have an employee that's working at your company, okay? This employee is a cool individual, right? They work at your company for a long time. They send messages on your internal system, or they make a claim on your internal system, and this employee now retires, right? They no longer work at your company because they're old. They're like 65, right? They're retired. You don't want to delete their messages, but you're never going to use those messages ever again. So what do? You archive them. You hide it, because one day when that employee's great grandchild wants to claim pension or whatever, you can prove that the employee worked there for other messages. I don't know. It's a crazy hypothetical, but you don't delete stuff. Hi, so sad you're not hopping on Arc today. Stand proud doing your coding thingies. Skibidi Zestin. Your boy's working hard, right? I'm programming so I can do this assessment. I don't know what to tell you. But we're working hard, boys. We're working hard. Let's get straight back into the solution, right? So we're part of a basic backend engineering team. Add a booking, create a booking, edit a booking, delete a booking, okay? Playing Arc, of course. Get out of here. Go play Arc. I'm busy. I'm contributing to the economy, man. I'm working hard, right? Okay. So next, we need to add a unit test or a front-end, console, web application, etc. Just show that's working. So basically, the scope of this assessment, I guess, is we're building a back-end, right? Which means if you're doing a back-end, you need to show that your back-end's working, right? So that's why we have a front-end, just to like sort of display that, right? The scope of this particular assignment or assessment or whatever wants us to either create a unit test or a front-end, right? We're going to jump into all of that. I'm probably going to make a front-end and a unit test, depending on how much time I have. But we're going to work hard, boys. We're going to work hard. We're going to have a long day today. We're going to have a long day tomorrow, and whatever we get done in that time, that's it, right? So let's look at these preferred tech stacks down here, right? MVC, .NET Core, Web APIs, jQuery, JavaScript, JSON, HTML, CSS, GitLab, Visual Studio, SQL Server. These are just words. Right, these are just words. So I'm gonna break these down. Not that I don't understand, but some of these you need to Google in order to like properly get your hands on it, right? So like everyone knows, or everyone that works in the industry has touched on a majority of the concepts. Like for example, I've worked as a programmer for I'm going 3 years now. Generally, when you work as a programmer, you will jump into one particular tech stack or two particular tech stacks that you do a lot of work in. So I've been lucky enough to be on quite a few different projects spanning a whole bunch of different clients and different things that we work on, right? But during that time, a majority of the programming that I'm doing is Python and Angular, right? There are a lot of programming languages, a lot of different disciplines. So when I say, hey, I'm a programmer, are you C++, C Sharp, are you Python, are you Swift, Haskell, Rust, F Sharp? There's a lot of disciplines you can go into, and each technology, each tech stack has pros and cons depending on the problem that you're going to solve, right? So just to keep things simple, we're going to be focusing on these particular tech stacks. So I'm actually going to break down how we're going to go about solving these problems, right? Step number one is literally we need to understand our requirements. I'm going to write that down. I'm going to solve this problem as if I'm doing it literally, like I'm solving the problem. I'm just documenting how I solve the problem type thing. And I'm going to be breaking everything down so that you guys understand and everything is properly researched for when I actually need to explain this solution, right? So we're going to understand our requirements. Nothing else we can go beyond that. So how do we understand our requirements? Well, Google it, boy. But now the problem is, for this particular assignment, we cannot use any AI. So generally, how I would approach a solution, or let's say I don't understand a certain concept in whatever I'm working on. So for example, we're going to get into it later, but in Python, when you handle migrations, how do I break this down? Okay, so let's say you are working on a database, right? Now, I have a database, and a database has a table with many rows. And in this table with many rows, I made a mistake. So let's say I named a column one thing, it should be named another, right? I need to change that. Now, what is a proper and efficient way to make that change without causing a lot of issues, right? Obviously, if you named a column wrong, all of your code needs to change as well, but we're focusing specifically on the database here. I'm trying to explain the concept. Generally, how you would handle that is you would update whatever you're updating, and then you would make a migration. Now, migration is simply just a form of version control. I had a reason I'm explaining this, but version control, right? So in Python, the way you would handle version control is you would have something called a limbic, right? It's a package that you can install and you implement it in your solution. You can create a class that sets up your models or whatever. You pull it into a limbic and it automatically handles migrations for you, right? If you guys don't understand something or you want to know a little bit more, just throw a comment there and I'll get to it. But until then, I'm just going to continue with my tangent and my understanding of the requirements. Bottom line is you need to Google some things, right? A programmer is not going to understand everything 100%, right? Your job as a programmer is you're solving a problem, right? How do you solve a problem? You use resources. What's the greatest resource on the face of this earth? Maynards. Second greatest resource on the face of this earth is Google, right? But Google has built-in AI. Google has an AI built into the search engine now, right? So if you want to Google something now, first thing that pops up is AI, and then you followed by a whole bunch of search engine optimized web pages, and you got to sort of sift through that stuff to get what you're looking for. So if I'm going, the point I'm going to make here is, if I'm going to Google it, it's going to pop up AI, right? So what I found to make this a little bit more efficient, right? And a little bit more, it makes more sense and it produces better results in my day-to-day, is I'll use Grok. Grok is an AI made by Elon Musk, and Grok is really good because it makes use of web scraping. Now, web scraping is basically a bot that goes on the internet, it goes on your website, copies and pastes, copies all the relevant information, pastes it into its own AI, and then Grok just formats it nicely for you. But Grok has a feature that shows the original web pages that it web scraped. So instead of using the slop that gets produced, sometimes it's useful. I'm not going to say it's not useful. It summarizes your things, writes some code for you. But if you're using AI to write code, come on, you're not using your full brain. Anyway, I use web scraping from Grok to get better access to relevant documentation, right? That is why I use AI. It is the most superior way of using AI. You still use your brain, but when you write a piece of code, you still feel like it's your piece of code, right? And by default, you can still claim that, no, I don't use AI to write code, right? That you can still make that claim. Number 2, if you copy and paste code into Grok, you're training their AI, and you're probably letting proprietary data reach outside of your local environment, which is a big no-no for compliance. So do not do that. That is very bad. So bottom line is you got to Google your stuff. So this is literally the process I go through to Google stuff. I'm not using AI. I'm not using Grok. I'm copying this, copy, paste, and I'm going directly to Google. Oh, I need to close this stuff. And this is a repository. We're going to Google. I hope I didn't release anything too sensitive there. We're going to Google, the AI mode, you see there. And we're typing in MVC, right? So what is MVC? Model View Controller. It's a popular software architectural design pattern that separates application into 3 interconnected components. Model, data, view, UI, controller logic to improve code organization, maintenance, scalability. Model manages the data, business rules, logic of the application, directly manages data. View handles the display and layout of the application, showing data from the model controller. Okay, let me take this and let me explain it in a way that makes sense, right? I hope that you guys can see on your mobile, not on your mobile, sorry. I hope that you guys can see on the other view. I'm gonna try my best to put this in the middle and then just do it. Let me make this a little bit bigger so you guys can see. Okay, cool. So I'm going to do a very basic diagram that should make sense, right? Now, you as an individual, right, who uses the program, right, you are called a, let me just make this smaller. You are called a user, okay? Because you are using the application, right? You're a user. How do you use an application? Right, you go and you use your beautiful computer, right? We're gonna build a little computer there. It's got a space bar, it's got an exit button, it's got a beautiful little screen here, right? This is called a client, right? This is very basic, right? A client is just fancy terms for a computer, right? It's your computer. Client, computer, same thing, right? Now, in order for your computer to work, right, it needs to make a request, right? It needs to make a request to a server. We're going to pretend that a server is just a big box that's filled with many server racks. Server. Okay, this is a basic example, right? Your client makes a request to a server, and then on your server, it will have your back end, right? Remember earlier when we were talking about back end and front end? Your server holds your back end, and the client holds the front end. Now, obviously, when you're hosting the stuff, your front end and back end is stored on the server. But for the purposes of this demonstration, the purposes of this particular stream, what we're trying to go for, we're trying to take difficult concepts and break it down to ways that you guys can understand, right? So very basic. You as a user are using a client, you need to make a request to a server, and then the server spits back the web application, right? Or the pages or whatever that it needs to render for you, and it will return the front end, right? It will return the whatever web page you're using on, right? So that's a very basic flow that we're going on here. So let's go back to what I was trying to discuss, right? What was it called? MVC, model view controller. We're gonna actually copy this literally like this. MVC, model view controller. Yeah. Hopefully you guys can see there on your thing here. So let me just move. Okay, cool. Model view controller. Now, if I'm reading this stuff correctly, MVC is a popular architectural design pattern that separates application into three interconnected components: model, view, and controller. So let's actually look at this diagram. The controller sends data, the view responds, request information, response information. Okay, so basically what they're trying to say is the MVC is basically how you structure your application or your system in such a way that it separates the different components, or it separates nicely the flow of your application. So what does this mean? Right? So remember earlier when we were talking about the client, right? This user here represents the client. We're going to do this. We're going to do our best version of that, right? When you, as the user, make a request on the front end, you remember you're clicking a button, that needs to go somewhere, right? That needs to be controlled. That's why we are going to hit your controller, right? Now your controller needs to speak to somebody. Your controller, what you basically did is you typed there, you clicked a button. When you clicked a button, your client or your front end was like, hey, this guy clicked a button. What must I do? So it hits an API, which is basically a URL. It hits a URL and it says, hey URL, this is what I have, right? I am looking for something that looks like this. Can you help me, right? This is what I have. I'm looking for something like this. What does that mean? Where is that defined? That is defined in your model, right? That is defined in your model, right? It sends the request, right, in the this is very bad. Let me make it in a way that you can see. It sends a request in a way. It sends a request in the form of a payload, all right? So basically, you will have the model that's defined on your back end. It will, hey, get out of here. I don't know. I'm trying my best here, right? I'm trying my best in a way that like breaks it down in a way people can understand, right? So you have a controller. It sends a request in a form of a payload. Generally, you will have that same model defined on your front end as well as your back end. If you don't, is a problem, right? And the model will also have the response, right, that the front end is looking for. It will have both of that defined, and it will spit it back to the controller, right? And then the controller will send that response back to the view. What is the view? It is your front end, right? And your front end will throw it back to the user. I think this makes sense. If I'm not understanding something, then you know this is proof that I'm doing it live, right? I'm just trying to break down something in a way that makes sense, right? So hopefully I got that in a way that makes sense. As we program, I will break it down even more, and I'll just show you guys how I generally do it or what I'm used to. And then from there, we will go about that. So here we have an ASP.NET MVC pattern. So we'll just open that and maybe give it a bit of a read. So ASP.NET is a design pattern for achieving clean separation of concerns. Now let's just quickly Google what separate of concerns is. You gotta research a lot when you program. So separation concerns is a design principle that divides software into distinct, specialized sections, each addressing a specific responsibility. Cool. Model View Controller, MVC, is a design pattern used to decouple user interface, which is your front end. Hey, I got it right. Data, your model, and your application logic. This pattern helps to achieve separation of concerns. Using the MVC pattern for websites, requests are routed to a controller that's responsible for working with the model to perform actions and or retrieve data. The controller chooses the view to display and provides with the model. The view renders the final page based on the data in the model. Okay, I think I nailed that in my explanation, right? So here is some C# stuff. Let's quickly just cover what ASP.NET is. Yep. So ASP.NET, right, is a free open source server-side web application framework designed by Microsoft for building modern web applications. It's basically a framework for how you will specify your API, your microservice, blah, blah, blah. I'll cover APIs and microservices because we will have that in the course of our development here. Ideally, I will have a microservice for the backend and a microservice for a front end. So let me just quickly maybe touch on that. So when you program, generally you're going to have multiple people working on the same program. If it's just you programming, you should be doing this too. But you're obviously not going to have everything on your local machine. When I mean local machine, that's your computer, right? Your local device, right? What is in front of you, what you can see, what you can touch, what you can spit on when you're angry that your code doesn't work, right? That is your local device. Generally, you need to store it somewhere on the internet. So one, it's safe, and two, you can have multiple people working on that. We use GitHub for that. GitHub is basically where you would store your repositories. GitHub allows you to basically have a bucket. Think of it as a bucket that you store your code in. When I want to work on this program, I will look in the bucket. I'll pour whatever's in the bucket in my local machine, make any changes that I want, and then I will basically do a pull request, which is like, hey, please can I save what changes I made into the bucket? Do you guys agree? You guys meaning the fellow people working on this program. If someone in your team says, hey, the code you wrote is not terrible, you may save it in the bucket, and then your pull request gets pulled through and that. But basically what that allows is it allows multiple people to work on the same thing at the same time, and then the only time your original thing will change is when you make a pull request, and every time you have a change that you don't have in your own machine, you will just say, hey, bucket, do I have any changes? And the bucket says, yes, you have some changes. And you're like, cool, give me the changes. And then everything is synced up and you're all working on the same thing. I had a tangent. Okay, microservices. Now, the reason this is important is when you save a piece of code that you're writing on, you're saving a system, there's multiple ways of writing the same system, right? When you have a front end and you have a back end, those are two different parts of your system, right? So a very common way of making a program is you would have your front end in one bucket and you would have your back end in another bucket. And we call that microservices because it is one service, your front end service, your back end service, and it is micro because it is small, right? The alternative to that is to have your front end and your back end stored in the same bucket. We call that a monolithic structure, right? So let's get straight back into what we're trying to do here. We're trying to write a program. So we Googled what MVC is. That covers basically everything we need to research. I love your your coding yapping. I don't get a thing, but it's cool. If you don't, I'm trying to break it down in a way that you guys can understand. But yeah, the Chinese cat speaks CCS. This guy has been programming for 500 years. He knows everything I'm talking about is terrible. Doing well, man. Caveman term. Yeah. Love you a lot. Mwah. Thank you for the support. We're breaking down our problem so that when we actually get to programming, it's going to make it a lot easier because we've done the ground research, right? So let's get straight back into it. So we've covered MVC. Let's cover .NET Core. So we've covered ASP.NET. ASP.NET meaning the framework of building modern web applications. And something similar to that would be probably Fast API in Python terms. So it's just a framework for Python, and .NET Core is your framework, or ASP.NET is your framework for C#. So .NET Core, now simply known as .NET, is a free cross-platform open source developer platform managed by Minecraft. It is the successor to the .NET framework used to build various types of applications. So what is the difference between ASP.NET and .NET Core? Let's Google that. Between ASP.NET and .NET Core. So ASP.NET is a web development framework that runs exclusively on older Windows, on the older Windows only .NET framework. ASP.NET Core is a complete redesign and the modern successor. Okay, so ASP.NET and ASP.NET Core is just different versions of the same thing, but that doesn't really answer my question of what is the difference between ASP.NET and .NET Core. .NET Core, okay, I'm going to assume everything's just the same thing. But cross-platform, unlike the original .NET framework, which was Windows only, .NET Core or .NET runs on Windows, Linux, and Mac OS. Open source, high performance, modern. Okay, so it looks like ASP.NET Core is an extension of .NET that is specifically used for building web applications and API. And .NET Core is a framework that you can use to build any sort of application. So a web application is basically an application that runs in the web, as the name implies. So when you go to your, let's say you program your front end, you program your back end, you run it, you type a URL into your Googles, and your local host and everything will basically display your web page. So we're going to be working in ASP.NET Core. I'm glad we Googled this because that's interesting. So let's get straight back into the content. Web APIs. What is a web API? A web API is a mechanism that enables two different software systems, typically a client and a server, to communicate with each other over the internet using standard web protocols. Are you gonna play Sims, sweetie? Oh, enjoy, baby. Okay, so let's get into this. Now, remember when I said you have a front end and you had a back end, right? The front end makes requests to the back end. Your front end is like, hey, back end, I have a payload for you, right? Accept my payload, but I need this in return, right? This is what I have. This is what I want you to give me. Can you give it to me, right? To facilitate that communication, where you say, hey, front end, or when front end says, hey, I need something from the back end, right? Your client referring to your front end and your server referring to your back end. The way they communicate is you would have a application programming interface. So when you define that URL that you hit, when you have an HTTP protocol, you hit an API. Your API is basically just a URL, and when this URL is triggered or hit in any capacity, your server will run, or it will run a script or a function or whatever that is managed by your controller. So that hopefully ties that into everything. I think I've explained that right. jQuery, let's quickly go into jQuery. I think I know what it is. What is jQuery? So jQuery is a fast, small, feature-rich JavaScript library that simplifies client-side scripting of HTML. Its core philosophy is write less, do more by wrapping many common JavaScript tasks into single lines of code. DOM manipulation. jQuery simplifies the process of finding, selecting, and modifying HTML elements. Using easy-to-use CSS like selectors and methods. Okay, so this is a can of worms, right? So generally, when you are programming a front end, you will use a framework that makes it a little bit easier to manage the different components of your front end. Now, typically, that's words. What does that mean, all right? Let me educate you. In a front end, I have a button, right? But generally, I won't only have a button. I'll have a button, I will have a drop down, I will have a structure that I follow in the web page, I will have a sidebar, a nav bar, I will have a really complicated table component that displays a lot of different data key points. And all of that is really taxing on your front-end code base, right? If you had to put all of that in a single file, that file would be massive and it would be difficult to read, it'll be difficult to make changes, it'll be difficult to maintain. So we have modern frameworks like Angular or React that manage those components in such a way where it breaks it up, and it basically makes it a little bit easier to maintain, right? So jQuery is a JavaScript library that makes it easier to script HTML. But you don't need jQuery in order to make a good front end, right? I generally use Angular, and Angular uses TypeScript, which is basically JavaScript with extra type safety. jQuery probably makes it a little bit easier to write JavaScript that can interact with elements in your front end. DOM elements, document object module. I'm not going to get into that now because it's just a can of worms to explain. But long story short, jQuery does event handling and DOM manipulation. All of the features of jQuery is handled by a good framework. So we're going to skip all of this. Having a front end is not a requirement for this assessment, but if we're going to have a front end, I'm going to do it in Angular just because I want to. Simple as that. Now, let's take a look. What is JavaScript? Now, as I said earlier, if we're going to do Angular, Angular makes use of TypeScript, which is basically JavaScript with extra type safety. JavaScript is a high-level dynamic programming language and core technology of the World Wide Web. Alongside HTML and CSS, it is primarily known for enabling interactive web pages, but its use has expanded significantly into server-side development, mobile apps, and more. So, why is JavaScript so amazing? Back in the day, when everyone was programming in PHP, they were programming with JavaScript in the browser, and you have a whole bunch of different technologies responsible for different things. JavaScript stood out because, what is JavaScript? JavaScript is a programming language that is used when I click a button. that fires off something called an event. When I click a button, what must I do, right? The event is what triggers when you click that button. I think that makes sense. But how do I know that the button's been clicked? I need to write a piece of code that basically listens for if a button's been clicked. I click a button, it fires off an event. What must I do once this event is fired off? It needs to run this piece of code. JavaScript is amazing because it handles those events. It basically targets a specific element, or a button in this case, and it says, hey, if this button is clicked, it is going to fire this piece of code. Now that works only in the browser. But with the invention of Node, it allowed the single tech stack, this is single programming language, to be run outside of your browser. So for the very first time, touching wood in case I'm wrong, I'm junior, remember that. For the very first time, you could write an entire program or system, front end and back end, in a single language. That is why Node is so powerful. You can even write lambdas. You can even write AWS stuff in it. But anyway, that is why JavaScript is so cool. But what makes JavaScript so amazing in the browser today is seen as clunky, because it is a lot of extra code that you need to write in order to make it work, right? That's called boilerplate code, right? So having a framework or front-end framework like Angular takes this boilerplate and it makes it that much. So instead of needing to know this much, you only need to know this much. And it makes programming or implementing a front end that much easier. So we're going to be going with Angular just because it covers jQuery and JavaScript stuff. If I need to know this stuff for this interview, let me not discuss that. But yeah, for the purposes of this application, let's continue. What is a JSON? JSON is simply a object that is used to store information. So in programming, JavaScript object notation is a lightweight text-based language independent data interchange format designed for easy human reading and machine parsing. Okay, so basically it is an object that you can use to display different kinds of information, right? And it is really good because a JSON can be processed by multiple different languages. A JSON can be passed from backend to frontend. A JSON can hold different data types. It's used in a wide array of applications. So this is what a JSON looks like, right? You have the name of your, I think this is called an attribute or whatever, your row. And the name of this particular, I think it's called an attribute. The name of this particular object is John Doe. His age is 30. Is student false? So basically this is a Boolean. You get different data types in programming. This is a Boolean. And it's basically saying, hey, is this guy a student? False, meaning he's not a student. Skills include JavaScript and Python. So basically this is a array, which is basically like an unordered list, and it contains JavaScript and Python. So what skills I have, I can code in JavaScript and Python. Address, so this is now this is an array, so it's one data object, and this is, I believe, is a list. So this list contains city, which is a key, and New York, which is the value, so a key value pair. And that is how you link these together. And an array, you don't have a key value pair. So this is a array. This would then be a dictionary, key value pair. It would be a dictionary. I think I covered this quite nicely. So let's move on to the next thing. HTML and CSS, I'm just going to very quickly cover it. So basically in a front end, you need three different things, right? You need to know where the button is on your web page. You need to know what color the button is going to be on your web page. And when I click the button, it needs to do something on my web page, right? The structuring of your web page, right, is managed by HTML, your hypertext markup language, right? CSS, I think it stands for Cascade Styles Processing what? Let me Google it. Cascading Style Sheets controls the layout, controls the color, basically some styling stuff. So let's say I have a gray box, right? There's a difference between how a gray box is structured in a web page, right? Like on top of each other, like without any CSS, it would be gray block, gray block, gray block, gray block, right? But with CSS, you can structure it in such a way that the gray blocks are either next to each other in a column, taking up the whole web page, and you can make them round. You can change the color. When you hover over it, it looks different. That is managed by your CSS. And when I click the button, what does it do? It fires off an event, and that's managed by your JavaScript generally. Everything's just JavaScript at the end of the day, guys. Okay, GitLab, I think this is like, what is GitLab? So GitLab is a comprehensive web-based DevOps platform that provides a single application for the entire software development lifecycle. It enables teams to manage Git repositories, track issues, conduct code reviews, and automate CI/DC pipelines in one place. Okay, so basically GitLab is like GitHub, but your repositories, instead of the bucket being on GitHub, the bucket is on GitLab. So everything that you can do in GitHub is where you can do it in GitLab. It's source control management. I generally don't use GitLab. I've actually never used it at all, so I only know GitHub. So technologies change with wherever you go, but everything is problems. I hope I'm not muted. Great. Everything is problems, but how you solve the problem is, there's 1,000 ways to kill a cat, right? And that's why we use programming languages. That's why we have all these different tech stacks. So we can have many different ways of solving problems. Visual Studio. Visual Studio is an IDE. It is how you write your code. Because like, I'm not going to write my code in a text file, right? I'm going to make it in a proper application. And that application has a built-in debugger so that I can actually run my program. It stops at a certain point. I can hover over the values to see, hey, what value are you? Hey, what value are you? This is what Visual Studio looks like. So I don't actually know if you guys can see it on stream. So I'm just going to pull that up actually. So, hey, you guys can see enough to get away with it. Get out of here. Okay, cool. ASP.NET, I think I've covered a lot of that. SQL Server is a database, all right? And there are many different ways in which you can manage a database. Personally, I use Postgres just because I know a way to make a very quick Docker image for it. And if you solve the problem once, generally, it wouldn't make sense to solve the problem again. So like, I have a solution, it works, it is widely accepted, I'll use that solution, right? If the purpose of this assessment is to demonstrate our knowledge on programming, I think we can get away with using Postgres. And it will also allow us to look into Docker. It'll also allow us to practice some of our Docker Compose stuff that we can cover. persisting isn't a requirement, and if I have time, I'll implement it. But for now, I want to focus on getting the basic structure of our system online, and I want to basically hit our program, and I want to make sure it works. So the way we can do that is maybe with Postman. If I do that, then I'll just hide my screen because I didn't set up my Postman for the stream. Because I do have some proprietary stuff on there, so I might just hide that. But let's get straight into the cookies and cream, and let's maybe start programming. So number one, we now thoroughly understand our requirements. So we need to now figure out a starting point. Step one, right? We need to set up our repo. So we need to create our bucket. And when we create a bucket, we need to make sure that when we are done programming, we have a place to save it. So let's set up our repo, very, very basic solution. And from there, we will pull it into a repository manager like Fork. And then we will eventually pull it into Visual Studio Code. And yeah, so let's get cracking with that. I'm just going to make a brand new repository. We're going to name our bucket. I'm going to name it... what do we... Let's read it. We're using to make bookings. So we're going to call this booking backend. Very simple, right? Description. This backend is part of an assessment where I for holiday goers. So I'm just writing a quick description. Goers. I think I can spell. That is how you spell goers. Goers. I'm going to make this public only because when I share this repository or when I am finished programming, I need a way to like actually save the work. So I'm going to set it to public. I'm going to add a README. So what this is, it's basically a little text document, or it's basically a text file in your programming, and it makes it a little bit easier to manage. So git ignore, I'm not going to add a git ignore yet. When we need one, I'll make one. So let's go and create our repository. Okay, I'm actually going to maybe, actually, I don't think it matters. Let me just copy that and then I'll pull it. Open repository. Yeah, that's why I did that. Let's save this directly to desktop. Hopefully I didn't dox myself. It's fine. Whoa, what am I doing? Let's make a new folder. We will call this folder bookings. Just very simple. Allow app. Always get this app. Alrighty. Bookings. Let's create this folder. The directory is not under Git source control. Initialize Git repository here. Detached head. Ew, that's weird. Hold on. There's a README. Why are you doing this? Why are you doing this program? Clone repository.
Am I cooked? Hold on. So this is just going to be me doing a lot of just troubleshooting. This is just me like live programming. So obviously when you live program, I opened it instead of cloning the. Okay. So when you clone a repository, we're basically saying, hey, bucket, I want to copy whatever you have in the bucket, and I want to put it in my personal personal PC. So that's what we're going to do. You got this, bro. Mwah, Wolfens TV. Thank you. I'm actually sweating here, bro. Yeah, so we're cloning it. We're making sure it works on our side. Cool. So every single branch or every single bucket by default has a main branch. Now think of in your bucket, think of it like a tree, right? There's a tree in a bucket. Just hear me out. And in this tree, you will have your main trunk, right? You'll have your main trunk. And obviously when you have a tree, the tree grows. Now, as the tree grows and your code base grows, it branches out, right? And eventually, think of it like it branches out, it gets a little bit bigger, and when you save it, it goes back into the main tree. It branches out, it goes back into the main tree, right? When you branch out, think of it as a branch growing out, and you work on a specific feature. And once the feature's done, you want to save it, and you want it to go back into the main tree, right? So you work really hard, and now you save it, and now it's going back into the tree. So we're going to make a new branch very quickly, right? And we're going to name this branch dev. The reason... Now, when you work on a program and you have different teams, generally, having a lot of people work on the same code can lead to issues, right? Dev is a minefield. And generally, dev won't be 100% working all the time. Only because I'm a person, someone else is a person, someone else is a person. We can all have different views of the same problem, and we can have different ways of interacting with that problem. And the way I solve this problem might not 100% fit in with how you solve this problem, right? So when you try and combine everything, it might not gel all the time, right? So just to protect that main branch, you have another branch called dev, that if there is an issue, it affects dev. And this main branch is always 100% working. And just having that separation, it really helps. So we're going to make a dev branch. And when you update your repository, you push. Okay? Maybe it wasn't a good idea to make this public yet. Let me make this repo private, just because I don't know if someone else that's watching this can quickly go on the internet and like copy this repo and delete the entire thing when I'm done. I'll be so sad if that's the case. So before anything happens, I'm just going to quickly make this private. Change visibility. Change to private. I want to make this repository private. I've read and understand this effects. Make this repository private. Okay, now we are Lacquer safe again. So no one on the internet can just copy and paste this. It's fine. Or I'm pretty sure you need to be added as a collaborator or a contributor. But yeah, we'll cover that bridge when we get there. Okay, so we're here. We're now saving to that original bucket, dev. Now, what I'm going to do now, the way you're supposed to do it is you need to, whenever you work on a program, you're going to have a lot of meetings in a team. They're called sprint planning, they're called stand-up, they're called whatever. But basically these meetings are like, what am I going to work on today in this program, right? You're not going to just go in and be like, make up what you're going to work. There's generally a list of things that you need to do as a programmer within a team, within a particular project. And basically think of it like I am a line cook in a restaurant, right? I'm not just going to cook whatever, right? I'm going to have an order, a slippy. I'm going to have a ticket. That is what they're called. It's called a ticket. So I'm going to take the ticket. I'm going to read the ticket. And this ticket says, hey, I need to implement this. I need to implement this feature, right? This is what I want. Make it happen. Then I put the ticket in. I write whatever code I need to do in order to do that particular functionality or fix a particular bug. When I'm done, I will save it or make a pull request, which means, hey, bucket, can I save my work into the bucket? And along with that pull request, you attach your ticket. So there's like a receipt of what you're working on. So we're going to simulate us having a ticket, and we're going to call this particular ticket a very big one. Just implement project structure. Okay, very basic, right? Now I'm going to open this. I want to open this. The default one is Visual Studio Code, but I'm actually going to try and open it directly into Visual Studio. So we're going to file, we're going to open a project/solution. I think it's project/solution. Desktop, we're going to go... Why are you... Oh, that's the OneDrive. We're going to go here. Hi, Bo. Where's my... Oh, it's in bookings. Booking backend. And then... Oh, you can't do that. So when you open a project/solution, it's looking for like a project file. So this would be a good time to actually research how to initialize a project in Visual Studio. All the projects that I've been on, they've done that already. So it's never something... can't you open it through fork? You can, but it's like a default one. So I've had projects do it through fork here as like a default. I have Visual Studio Code, but we're going to be programming a C#.NET program. So let's research how, right? So how to open repository in GitHub. In Visual Studio. Yeah, that's fine. So to open an empty repository in Visual Studio, the standard approach is to clone the repository from its remote location to our local machine. That's what we did in fork. And then open the local folder in Visual Studio or initialize Git in the initial folder. Okay, so we're basically going to be going here, file, and instead of doing a project and solution, I'm going to go folder, desktop, not that desktop, bookings, booking backend, select folder. Alrighty, we're in it, right? Here is our program, our solution in our solution explorer, and we've got our readme here. Let's open our readme and see what it says. Booking backend, this backend is part of an assessment. No stress, Wolfens, don't you worry. So let's take a look at what's going on here. I want to just look on the mobile thing to see if you guys can actually see. This is kind of butt for you guys actually. So let me maybe make it smaller. And then I'll just position it so you guys can see it nicely. There. Okay, cool. There we go. You got a subscriber, man. Thank you. We're programming live. We're trying to get this thing cranked out. 228 subscribers. Why do I have so many subscribers? I just refreshed it and I got like 9 subscribers. That mwah. Lots of kisses for you guys. Thank you. Okay. Let's get back to the original problem. Quick thank you for all you beautiful people subscribing, coming along the journey. We're programming from scratch here. No AI. We're doing an AI detox. Let's have a slicky. Okay. Let's continue. So, let's give a read. An empty repository generally means one thing has been created on hosting service like GitHub or whatever. You've already... Okay, so now that we have our bucket open in our IDE, Visual Studio, we now need to initialize our project. So generally when you have a C# project, you will have a startup.cs, you'll have a whole bunch of config, and when you run your config or you run your server, it will run your program. So what we're going to do is we're going to research what that basic file structure looks like. We're going to research how to initialize it, and then we're going to research the proper folder structure of your controllers, your models, and your services and stuff like that, just so we can have a good starting point on how to expand this project. And then we can maybe start filing out the basic APIs that we're going to hit, and then we're going to file out the basic functions that we're going to have as well. So let's do that. How to open or how to initialize a basic C# project. To initialize a basic C# project, you need the .NET SDK and a code editor like Visual Studio. We already have Visual Studio. The process typically involves installing this process typically involves installing the necessary tools, creating a new project, using a template, and then running the default Hello World application. So let's research how to do that through a proper doc. I don't want to use that AI generated nonsense, man. C# get started. Great. W3 schools. So C# IDE, the easiest way to get started with C# is to use an IDE. An integrated development environment is used to edit and compile code. In our tutorial, we will use, oh, by the way, new people, join the Discord. Don't be weird. Join the Discord. Normally we stream Arc Raiders, Minecraft. We do crazy things. I want to do crazy things with crazy people. So I need crazy people. Join the Discord. Don't be weirdo. The easiest way to get started with C# is to use an IDE. In our tutorial, we will use Visual Studio Community, which is free download. We've already got something similar. Applications written in C# uses the .NET framework, which we researched earlier. So it makes sense to use Visual Studio as the program, framework, and the language will all be created by Microsoft. Okay, so we already installed this stuff, so we don't need anything else. This is what it looks like. This is what it looks like. It looks like they created a blank solution. So we might have to restart how we did this. Okay, let's do a quick and easy solution. So we have our folder already open here. So we're going to do something different, right? We're going to close all of that. We're going to create a brand new project. And then we're going to follow this tutorial. And then we're just going to copy and paste the code over our entire repository. Once the Visual Studio is downloaded, click the modify. We're reading documentation. Create a new project. So this is where we are, right? So all languages, C#. Let's do a blank project. It actually needs to be an ASP.NET. C# Linux. Okay, so this is the one we need. We're going to call this one booking backend. We're going to do, let's maybe save it in the same thing actually. Can be full because it's opening a new thing. Let me just close everything fresh. Let's close that. Let's look at bookings. Booking backend. It's already a versus thing here. It's already a readme here. So we're going to be cheeky. We're going to take the readme out. We're going to close this. We're going to open Visual Studio 2022. Create a new project. We're we are going to go, ooh, this wind that's coming through this window. ASP.NET Core. ASP.NET Core Web API. Let's do that. We'll call this booking backend. Source Timothy. Let's go desktop bookings, booking backend. Select folder, solution name, place solution, and project in the same directory. I don't think we need that. Doesn't make sense. We should probably follow the tutorial, right? Okay, so they're doing a very basic. Dimitri Weston, stay in school, learn programming, stick around, man. Take notes. Configure your new project. So this is project name. We've already done that. This is new stuff. Hold up. We've got the location solution. Okay, so they did a very basic thing. Let's do long-term support. Configure for HTTPS, which is what we need. Open API. Use controllers. I don't see anything here that is an issue. So let's create our basic project. Yeah! Okay. Let's explore what's going on here now. We're looking at our Solution Explorer. So what we did is we now created a basic boilerplate project. It's got a whole bunch of solution stuffies and it looks like this. So now what I want to do is I actually want to go back. What am I doing? Hold up. Let's look at my desktop. Let's look at bookings. Booking backend. Why is that there? Why is this GitHub here? That is scaring me. Booking. Okay, so it looks like this bottom level booking backend and this solution is that. Okay, cool. So I'm happy. Let's Control X this. And let's maybe delete this GitHub. I don't think we need it. Okay, that's cool. So I think everything works now. Let's save everything and let's see if we can open it through fork again. So if we look at our local changes, that is a lot of changes. Our README got nuked. So let's open up our folder again. Let's look at our bookings. No, I'm cooked. I want to copy this README back into our solution. But I don't know if this is the appropriate way to do it. Let's do it anyway. And then we will look back on fork to see if that's there. README. Now the README is here. Debug.NET object controllers. Booking backend, and then just a whole bunch of config stuff. Booking backend, but the README is there. Let's go to desktop, bookings, booking backend. Then this is the solution, and then the project file. Yeah, it's not going to get any better than this. This is fine, right? So this is our basic project structure that we got going on here, right? Very, very, very basic project structure. Now, I want to actually see if we can open it in Visual Studio Code. We configured it, so now we can open it properly through fork. W's in chat, boys. Massive W's in chat. We did it. We did it, boys. Okay, let's continue. W. Thank you.
Okay, we read documentation and we solved the problem, right? AI would have given you step-by-step instructions and made this process a lot easier, right? So that is why we didn't use AI. Some skills are just lost as technology develops, and you need to have strong fundamentals. So this is actually a good exercise. This is a good exercise. Wolfon's TV. I think I know your identity, but I'm going to keep it a secret because Batman needs a mask. So let's continue. I opened it in Visual Studio. We're going to look at our Solution Explorer. We're going to take a look at what these files mean. Weatherforecast.cs. What is this terrible thing? Hypo. Okay, so this thing gave us like a default class. It gave us a default thing here. I don't even want this readme here. I think this readme should be upper level. Let's get that sorted out before we do anything. Bookings, booking backend. Booking backend. We're gonna take this readme. I'm gonna paste it here. Okay, cool. How do I refresh you? Not refresh. Our readme is now not here. I'm sad. Why is our readme not here? I think it was in the right place. Sorry, this is just going to be a lot of me just manually trying to figure this out. Desktop, bookings, booking backend, readme. Readme, delete. Didn't I remove it? No, I didn't remove it. I put it back in the... I took it out and then I put it back in. And now I took it out and put it back in again. So don't you worry. Okay, so let's explore what these different boilerplate things mean. So let's read our documents. What do files in a C# project mean? Hanan AI, we're using general structure of a C# program. We're in the money. We're in the money. Variables, comments, methods. I'll get all this good stuff here. General structure of a C# program. So C# programs consist of one or more files. Each file contains 0 or more namespaces. A namespace contains types such as classes, structures, inheritance, enumerations, delegates, blah, blah, blah. Hey, man, I know politics. I know what a delegate is. Then a console write line, hello world. Okay, so these don't really go into depth on the different files. So I will have a crack at explaining basically what I understand. So these connected services are basically extra config. These dependencies, I think, fall into like the different packages and structures that your program needs in order to function. Properties, these are like your launch settings and stuff. Very, very, very scary stuff if you don't know what it looks like, what it means. Booking backend, object, debug.net. I think this just contains your framework settings. Assembly info inputs. That's fine. Controllers. Okay, so basically earlier when we were researching MVC, your model view controller, one of the things that was specified is your controller. Out of context, that would be wild. Get out of here, Wolfon's TV. Okay. So earlier when we were researching what an MVC is, your model, your view, your controller. One of the things that were mentioned there is your controller. So what is a controller at the end of the day? A controller basically is going to be that middleman between accepting a request from the front end and determining what to do with that request, right? And that logic and how to handle that facilitation is defined here in your weather forecast controller. Or in this particular case, it's weather forecast controller. We're going to change the names. But let's take a look at what this actually means, right? It has the API controller tag, and then it also has your base, your route, right? This public class, so public is an access modifier, meaning that this particular class is accessible for everywhere inside your program, right? So what is that class? So when you write a program, especially in an object-oriented programming language, you function off the 4 pillars of object-oriented programming. And I'm going to be a very bad programmer because I forgot one of them, but I'll tune you guys what I know. So the 4 pillars of object-oriented programming, let's look at it. Pillars of OOP. Okay, your 4 polymorphism, highball. Abstraction. Okay, so your 4 pillars of object-oriented programming are encapsulation, inheritance, polymorphism, and abstraction. So let's get into that. When you write a program or system or whatever, you're generally going to have many different parts, many different modular components that all interact with one another, right? And the reason you separate it is because you're going to have to firstly maintain this project at some point, and it's just going to be a lot easier to maintain small modular components instead of this giant massive code base. So that's one of the reasons among many. But another reason for encapsulation is when you encapsulate relevant sections or relevant parts of your program, it increases security in the sense of you can tie certain permissions to that class. I might be going on a bit of a tangent, but basically what encapsulation is you basically take a section of code and you put it in its own little block, and you access this little block through a namespace, and I think that makes sense. And basically it keeps everything modular, it keeps everything in its own little blocks, and makes it easier to maintain. I think that makes sense. Yeah. Inheritance. So a class is basically an encapsulation of some code. Inheritance falls on that same vein. What is a class? So a class is basically a section of code where you store certain attributes, certain methods that pertain to the class. So maybe let's open up a quick and easy paint thing here. Let's do it. Let's practice my 3D graphic design software, right? So let's say you have a basic class. I want to create an animal class, okay? An animal class. Now, obviously, I'm a professional because this is like, you find me a doctor in the Southern Hemisphere that can write as legibly as this, and I'll call you a liar, my bro. So this is an animal class, right? What attributes or what features would an animal have? Every animal on the face of this planet has an age, right? Doesn't matter if it's an elephant, doesn't matter if it's a dog, doesn't matter if it's a horse. Every animal on the face of this planet has an age, right? Every animal on this planet also has maybe the amount of legs, right? There are some animals that have 0 legs. There are some animals that have many legs. But sound, is my sound bad? Hold on. I just created the worst echo in the world. My sound's fine. You're scaring me, Wolfons. You're scaring me. I'm trying to explain stuff. I'm trying to explain stuff, Wolfons. Okay.
So basically, what we're describing here is we're describing a class, but we're also describing certain attributes or features within that class, right? So every animal on the face of this planet has an age. Every single animal on the face of this planet has legs. Now, what can an animal do, right? What method or what actions can an animal take? Every single animal on the face of this earth can make a sound, right? It can make a sound. Whether that be a bark, whether that be a hiss, whether that be a squeak, whether it be like a low guttural moan, like the type of moan my brother makes when he eats any sort of pastry, like something like that. Every animal is part of a species. Exactly, Justin. That is exactly true. Species, I would say, well, keep on that tangent, Justin. Keep on that tangent. I will bring this to you, right? So every animal makes a sound, right? And every sound has a noise, okay? So we're going to say, hey, this sound needs a noise, okay? I'm going to actually check the chat of the different stream. Nah, we shut. So every sound has a noise, okay? And this noise is basically text. It's word. It's something that I can read, right? So when you are programming, you're going to have different sort of data types. Meaning a number is generally an integer. A piece of text or like words, characters, that is generally a string. So let's say this noise has a string, is of data type string, okay? Now what we just did here is we created a very basic class of an animal that has an age attribute and it has legs, right? But we also created something called a method, which is basically a function that's inside a class or whatever. And what we did here is we created almost a base class, which is like the top level that you can be, right? So keep in mind this base class, okay? We're gonna take it and I'm going to make it a little bit smaller so you guys can see, right? We also have another name for this base class. We call this sort of, whoopsie, let me see if I can do this properly. Yeah! We call this base class a parent, okay? Because parents like to be in charge, I guess. I don't know why they call it a parent. Off topic, this is honestly taking me back to my first year introduction into programming. Yeah, man, this is basic stuff. But what we're doing here is we're basically doing a little bit of a challenge, a little bit of an assessment type thing. And if I'm going to like really understand what I'm doing, I need to explain it very, very nicely to you guys. And it's going to be a bit of a boring stream if I just sit here quietly and program. So I'm using you guys sort of as a way to like study this stuff, sort of as a way to like really get my fundamentals down, and I'm not using any AI. So a lot of this stuff, it's been a while since I've looked up, so I'm just like rehashing it. But anyway, back to the topic at hand. This is a parent class, right? Now, I'm going to tie this back into the 4 pillars of object-oriented programming. What we did here is we just encapsulated a little bit of logic into one class. So this is now an animal class. It is in its own little box, right? Now, what we're doing is we want to look at inheritance. What does inheritance mean? Inheritance means you have, if an instance or a child or an extension of a parent class exists, it will automatically inherit properties or behaviors from the parent. Now, that's technical jargon. What does that mean, right? Let's say I have an animal, and now I want to make a subclass, okay? Think machine gun and submachine gun, right?
So I'm going to make here a subclass. This is the parent class and the subclass. Also known as a child class. Right? So that's how we get parent and child. Now, what does this child class even mean, right? So let's look back. Let's... hopefully you guys can see it nicely. If you can't, then, zoom in or something. I don't know. Let me know if you can't see it properly. We will try and fix this. But you've got your parent class, you've got your child class, subclass. Now, what does this mean, this inheritance? Well, let's say I want to create an instance of an animal class, right? It will be basically something like this. Let's say I want to make a dog, a very simple animal, a dog, right? I'm defining now a dog class that's going to look something like that. The way we would create this is we create an instance of our parent class, so new, and then we take our parent class, which is called animal, right? And what are we doing here? Oh my gosh, I'm so good at this. We create a new instance of the animal class. So we're basically saying, hey, take the animal blueprint, copy, paste, and I want to store that object inside this dog variable here. Okay? So we're creating a new instance of the animal class, and I want to give it maybe... Am I doing this right? Hold up. For simple illustration, I think it's fine. Okay. So I'm going to make an animal class. Actually, I'm talking trash here. I'm not doing it right. Hold up. So now that we defined our parent class, we now need to define animal dog equals new animal. Yeah, sorry. Thank you, Wolfpants. Now that we defined our parent class, we're going to take a look at defining a child class, right? So now I want to define what the dog class would look like, the dog subclass. So let's take a look at that, right? The way you would do that is you would basically say this dog is an extension, right, of this animal class. Yeah, I'm so good at this. Yeah, I'm programming, man. Yeah! Okay. So this dog is an extension of the animal class. Now, what does that mean? What does defining mean in Latin? Google it, man. What I look like? Google Translate? Get out of here, man. Okay. So let's get back to the task at hand, because I'm freestyling here, man. So what we did here is we took the dog. We're now defining a dog class, and we have the animal extension. So what does that actually mean? In terms of inheritance, it means that these two attributes already exist in the dog class. We do not need to redefine it, right? But what we will do, since we made a, since we defined a method here that we didn't give the exact implementation in, we need to define it in this dog class. So the way we would do that is we would say, hey, the sound, okay, is going to be called a bark. Whoopsie. Control Z. String, whatever. Speak, and we're going to say bark. Alrighty, so let's unpack some things that we just did. And this is now in its own box. I'm going to get the exact name of what I said there. Google. What is it called? Method in a base class. And give the exact an abstract method. Yeah. That ties into all 4 of what we just did. Hey, nah, get out of here, man. Okay, so let's. It's a niche reference. Haha. Never mind. I'm listening, sir. Yeah. Interesting stream. I'm invested. Thank you, Wolfards. Mwah. You have no life. Why are you watching a junior detox from AI, man? Get out of here. Okay. So anyway, we're back into it. We just defined a subclass or a child class with the animal extension, right? We determined now that these attributes, age and legs, right, already exist in the dog class, right? We defined that these age and legs already exist in the dog class, and it is an extension of the animal. And what we defined here is called an abstract method. Okay. Now, what does an abstract method mean? It means you can define certain behaviors of a class, but you don't need to provide the exact implementation. Or by extension, you can hide really complex and insane logic, but you can hide it behind an interface. So when you interact with the class, you don't need to know the exact detail of how something is implemented. You can simply just call the name of the method, and the name of the method in this case would be sound. And now let me quickly show you how this would work. Okay, now we have this dog class that has a basic method in it, but now how do we go about using it? Let me just zoom out here. We'll go down. So we have the animal class, the parent class defined, and we have the dog subclass defined. So what are we doing here? We are now going to initialize this dog class. So the way we would do it is we would say, this should be a capital letter because naming conventions. Yeah, put the capital D in DOG. Okay, so what we are doing is we're now defining the type. So when you define or when you use a variable in your program, generally that program makes use of type safety. You know, shout out to raw JavaScript. But anyway, generally you will infer the types of whatever you're working with, only because whoever works on, you might know what's going on in this object, but if I just look at something and I have no context about it, I'm not going to know it, right? And it just makes structuring your component a lot easier. This ties also into MVC. So model, view, controller. View is your front end. Controller is the thing we're covering now. These would be your models, right? These are the types that you're defining. So we're tying into everything we just covered. But type safety is important because if you don't have type safety, your seniors will beat you with a stick. It has happened. Anyway, so now we're going back into this instantiation. So this dog represents the class, right? Or the type that our variable is going to be called. Your DTO is your models, data transfer object. DTO, model, model class, all the same thing. So here's your dog. So now what we're going to do is we're going to have the variable name. Okay. I have a variable called dog and it is of type dog, right? And now what we're going to do is we're going to instantiate this object here. So new and dog, right? But ladies and gentlemen, what happened here? We are trying to instantiate an object. This could have been done in an IDE, but I like my 3D graphic design software. We are trying to instantiate an object, but we cannot instantiate dog just like this. It will shout at us. It will cause an error, man. So what we need to do is we need to say, hey, remember those attributes that our animal class has that we didn't define in this dog? Those are required attributes, meaning we need these defined in order for our class to work. Because required attributes are generally used in methods, which I didn't include here because I'm a 10x developer, man. Anyway, back to the project, back to the problem. We now need to define the age and legs and probably, we need to define the age and legs of this particular animal. So the way we do that is we say, how do we do this? The way we do that is we say age equals, and let's say 7, and then we put a comma there, and then we say legs equal, we got 3 legs, right? Our poor dog has 3 legs. Sound as well. Thank you, Wolfon. Lots of kisses. Right? So now we have basically demonstrated all 4 aspects of our pillars of object orientation, 4 pillars of OOP by accident, right? So let's cover all of them. Encapsulation, okay? We defined a class and we put it in a box, right? We took a piece of functionality and we put it in its own little modular container so that we can use it in other parts of our application, like this dog subclass, right? And it was nice and easy because it was all encapsulated. Inheritance, right? Our age and leg attributes of the animal were automatically inherited by the dog. And it's demonstrated here where we didn't explicitly define it in the class, but it's still available for us to instantiate here at the bottom, right? Polymorphism is a funny one because it's a funny name, right? But basically what polymorphism is you can have functions of the same name, but they can have different parameters, and then they will be different. It'll basically be a different function. So I think I demonstrated it here nicely. In our abstract class, in our animal class here, we defined a method called sound, but we didn't give the exact implementation of that. And what we did is we have the same name here, right? But we overrode it. We did method overriding here, where we said, this is the name, right? Let me actually copy this. Control-C, Control-Z. We basically gave it the same name here. The name of the function. Oh my gosh, this... What did I do? Control-Z. I deleted my entire thing. Oh my gosh. Okay, this is the name of the function, alright? And these are the parameters. String, this is fine. And these here, over here, are the parameters, right? Name of the function, basically how am I going to call this function, how am I going to use the function, and parameters are what does this function need in order to work. Control-Z is your friend, brr, you have no idea. So what we did here is we used the same name of the function, but we also we gave it a new parameters. So we overrode the original method so that we can define our own implementation. That ties into polymorphism, right? And in that same vein, abstraction, we defined a particular behavior that we want our subclasses to have, but we didn't give the exact implementation. Okay, so we abstracted literally through a method. We created an abstract method. And let's say you use the animal class. No, the animal class would be a base thing. The other side of abstraction would obviously be just hiding complexity of your program. So I think this was a really nice way of explaining object-oriented programming principles. I think we can tie this one off nicely. So when if I ever get reviewed on this, they can say, yeah, +4 for your fundamentals. So let's get straight back into it. So we have encapsulation, inheritance, polymorphism, and abstraction. I
I genuinely cannot remember why I was going on this explanation, but let's get back into the problem at hand, right? I think last time we stopped off, we were looking basically at what these different things means. So I think we went on controllers, and then I went on to explain what a class was, and then I went into pillars of object-oriented programming. Okay, so let's look at your app settings.json. So you will have your normal app settings, which is like your default app settings, and then you'll have your development.json. So what I found, or what I understand from this, so JSON is one of the data structures we defined earlier, or we researched earlier. You were getting understanding of MVC. Yeah, we already covered MVC a while ago, but this was more object-oriented stuff. But yeah, MVC. So we went on the controller tangent. I explained what a controller was, how it worked, how classes sort of interact with each other. And basically, if I was like a grade 10 computer science teacher, like the class would be like going, ooh, right now, right? So we were in it. So let's look at this app settings.json. So what my understanding of an app settings.json is this is more like just a blueprint of how your config in your program should look. And then app settings.development.json is when you are working locally on your program. It will, oh, you guys can't even see the solution explorer, sorry. So that's app settings.development.json will be like your local development config. So let's say I have a particular variable that is very important for my program to run, but it's so important I cannot hard code it because it's also dynamic, or it's very important, so it's super secret. I would put it in my app settings.development.json, and just so I can work with it locally. And obviously, when our program goes to production or whatever, those secrets, or these secret variables they're called, will be stored in our environment and then called directly there. So that is cool. Booking backend.http. First time I've seen this in my life, except the projects I worked on must have been old, because I ain't never seen this before. I'm gonna have to research what this is. Damn. Program.ts. This is cool. This is just our starter project. It is weird seeing it this small. So obviously the project I've been working on has just been worked on forever, I guess. But I don't. Obviously the projects I've worked on is proprietary, so I'm not gonna give anything like that away. So yeah. C#. Yeah. Okay, README is just the basic like how-to guides for how to use your program. And this weather forecast.cs is just a naked class just hanging out there. So I think right about now we can start taking a look at structuring our project, right? So let's delete these classes. Can I Control Z? Undo. What broke? Probably something in here would have broken. Okay, so let's read what's going on here. We're gonna read our error. So basically what's happening here is we defined a function, a very basic HTTP GET. Oh, this was boilerplate stuff. And it was calling a weather forecast class that was down here that we just deleted. And what it does, it looks like it's just doing a range of 1 to 5, copying an index and just doing something random. Let's clean up our stuff. We're not going to use this. So let's rename it. Very basic. We'll call it our... Okay, so when you name a class, you got to actually think about what the class is going to be used for. So in this particular case, our rates going to be a booking thing. So this is going to be a booking controller.cs. That makes sense.
If you rename a file, would you also like to perform a rename in this project of all references? Yeah, do that. Okay, so we have this. This can be deleted because it's just static stuff. This looks like it's just doing a very basic logger, so we don't need anything like that. And we're going to delete this boilerplate. Cool. So this is now officially a very, very, very simple. This is now officially a very, very simple class or controller class. It doesn't link to anything yet. So what we're doing now, yo, I need a T or something. This is crazy. What did I do? Hold on. Why is there two things? Get out of here. I'm a dip because it's getting late. You're doing very well so far, bros. Keep it up. Wolfens, lots of kisses to you. What did I do here? Scroll bar options. Highball. I'm a file. I'm gonna save everything and I'm gonna just restart this. I'm too scared to deal with that. When your IDE starts shouting at you guys, just restart, man. Turn it off and on again. Yeah, fixed it one time. Okay, cool. So we set up our controller, and we set up our app settings.json, our other stuff, our programming.cs. There's lots of comments here. Does Swagger, does other stuff. Okay. So we got our controller and everything working. What I think I'm going to do now is I'm also going to set up our models. So let's add a new thing. In C#, it is called your DTO. So I'm also going to add a new thing here called adapters, just because I do anticipate us, is it adapters? Adapters. Okay, so let me explain what I just added. So in your MVC, your model, your view, your controller, your models are your DTOs. That's what they're called in C#. And your adapters is how you would like make calls to your database. That makes sense. And I don't know what this HTTP nonsense is, man. I think this is going to be some config of how we link to our controller. I'll have to see how that's being used. But the goal for today's stream is also, it's like pretty late. So we'll hop on early tomorrow and like do a massive stream and like till I'm done. But these are like just the fundamental building blocks that we're getting by. Let's take a look here at our requirements. We need to create a POC that will be used to help people going on holiday make bookings. This could be apartments, vehicles, shows, etc. The assumption we work on is that there will always be availability of what needs to be booked. We do not need any persistence. We're part of a backend engineering team. The requirement is for a basic solution that allows someone to add a booking, edit a booking. We need a unit test, and then these are our functions here. HTML, CSS, Visual Studio, SQL Server. Okay. So, the next steps I want to do is I want to set up the interfaces as well as the controller, as well as the DTO. Tim, you're going to be on VC today or no chance? It is already like 20 minutes to midnight for me. Directly after the stream, I'm going to go home. Not I'm going to go home. I'm going to go and sleep. And then from there, I have work tomorrow. And then maybe directly after my work, I will hop back on. I will hop back on stream. But like, I will stream again in 14 hours? In 16 hours, I'm going to stream again. 16 hours from now, at least. So let's get straight back into the content. I maybe want to set up a quick controller
Then I want to hit it in Postman, and then once I can navigate from the controller to the service to the adapter, then I'd consider that a win for this evening, and then we'll continue with it tomorrow. Let's do this. Services. Alrighty, I'm happy with this. So, what is a controller? What is a service? What is a DTO? What is an adapter? Controller, as we discussed, is how you control the request coming from the front end, and you send it off to whatever it needs to trigger in the back end, right? What needs to trigger in the back end? Well, let's say I have a payload, and this payload is asking me to do something like add someone to a DB, add someone to a database. I'm going to look at this request and I'm going to say, hey, request. I'm going to use a service to complete this piece of functionality that you're looking for. So give me the request. I'm going to call the service. The service has the particular method that solves your problem. In that service, when I make a call to a database, right, I'm going to have the type that I'm looking for, which we define in our DTO. Let me just pull this up so you guys can see. We're going to have the type here that we define in our DTO. And we're going to have the adapter that we use to interact with the database. So we've got an adapter, we've got a DTO, we've got our controller, and we've got our services. That is the basic structure of what we're working on here. So let's now look at our next step, our controller. We're going to look at our booking controller. I'm going to say, hey, booking controller. I, as a front-end individual, I'm going to make a call to the backend. The very first thing I'm going to do is I'm going to add something to the database. So I want to create. So that's going to complete this requirement here. I can't even see here. I can't even read. Allow someone to add a booking. So we're going to create something. We're going to add it to the database. We're going to add a booking. I haven't even decided what we're going to be adding, what we're going to be booking. I'm assuming we're going to define that at a later point. Yo, ladies and gentlemen, I'm about to make so much tea. My voice is like sore. I scream for hours while playing this game. While playing games, I will literally scream for hours. But the second I need to like concentrate and like actually program something, it's gonna be crazy. Anyway, so let's look here. Step number 1 is we now need to research how to make a call. So how to make a post request in C#. Right? Very simple. Stack Overflow might be the way. In .NET using C#, that might be the way. Okay, how can I make an HTTP... get out of here. How can I make an HTTP post request and send data in the body? Keep the grind, you go to... Skibbity, you go to... Join the Discord. If you're a nerd, you'd be in my Discord. If you're not a nerd, you'd also be in my Discord. Yo, I'm getting loopy here, boys. Oh, I need to take my antibiotics. I'll take it later. It's fine. Before I go to bed. Method A, HTTP client preferred, available in .NET Framework 4.5 standard. It is a currently preferred approach. It's asynchronous. Asynchronous meaning that two of these can run at the same time. And high performance using system setup is recommended to instantiate one HTTP client for your application's lifetime and share it unless you have a specific reason not to. See HTTP client factory for dependency injection post. These are terrible, by the way.
When was this made? Modify a year and 6 months ago. It was asked 15 years ago. This is old. In C#, how do you send an HTTP post request to a URL? Oh, we wanna... So this is not 100% what we're looking for. So maybe let's look here. We're basically looking for a tutorial on how to actually make a post request and stuff. How to not make a post request, how to C#. In C#, a controller is typically set up as a class within ASP.NET MVC or web API project that handles incoming web requests and returns a response. So in C#, a web project, ASP.NET Core, web app MVC or web app API. Open an IDE like blah, blah, blah. No, get out of here. This is AI generated. Yucky. Adding a controller in C#. Yeah, we're reading documentation today, boys. It's me, Zestine. I know it's you, Zestine. It literally has your name in the damn thing. Zestine was active this morning at 10 a.m. and he's still active at like 15 minutes to midnight. I don't know what time zone you're in, but the math ain't mathin', bruh. Okay, adding a controller in C#. Let's analyze. Mwah, I love you too. Okay, let's do this. What is this? 2010. Okay, so we added a controller. We did that already. We have a basic thing here. Inside the public class hello world controller block, create two methods that look like the following: control, and it will return a string as an HTML. No, this is not what we're looking for. How to set a controller in C#. With the URL. How to set up a customer. Okay, it seems my question is actually not a routing issue, but an anchoring issue. If I have an assigned route, that looks better, closer to what I'm looking at. How would I correctly use an ASP action to call this route? This looks interesting. Okay, so this is probably closer to what we're looking for. So let's do something like that. So I action result, and we're going to call this add booking. So let's hover over and explain why it's causing an issue. Not all code paths return a value, so we're just going to create a simple return and close parentheses. Why are you returning X? An object type of convertible to I action result. Okay. You can add several attribute routes to the action. Okay, that's crazy. Okay, let's take a look. Adding a controller.
Okay, so let me explain our problem. So what I am basically doing here is I am trying to define a particular route in code that when I put this URL into a browser or in Postman, and I attach an object or a payload, I want to be able to hit this URL and it triggers a certain event and functionality within our program, right? But in order to do that, I need to just research the correct config for it, because I've never set up something like this from scratch by myself. I've always just like copied and pasted it from existing stuff in the project. So this is a good detox for that, I guess. So let's look at... Yo, Nike bro, mwah, welcome to the channel. If it's your first time, join the Discord. We are programming, but we're detoxing from AI as well. So it's very important that we focus, very important that we not use the built-in AI in Google. But what we're basically doing now is we're setting up our HTTP routes for when we add a booking to our application. So we're reading documentation. We're going through it step by step. So it looks like this route right here is an ID. And I want to maybe see how we can do it better. How to set up a controller with a URL. That makes sense. Andrew Locke looks like he knows what he's talking about. Okay, so 8 ways to set the URLs for an ASP.NET Core app. So by default, without additional configuration in .NET 8 ASP.NET Core, apps listen on the URL HTTP localhost 5000. In this post, I'll show 8 different ways to change this URL. This is an update to a post I wrote 3 years ago. 5 ways to set the thing. This post is similar but covers some additional ways. There are multiple ways. So we can set the URL by calling web application. Okay, so what this basically is by default your application is on localhost 5000. He's changing that localhost 5000 to say something else. Control Shift T. That's not what we're looking for. We're looking for more of a... we're looking for how to define a route in a controller. So how to define an HTTP post in a C# controller. Let's do that, boy. Let's do that, boy. To define an HTTP post method in a C# controller, you use the HTTP post attribute to decorate an action method. This restricts the method to only handle post requests, typically used to send data to the server to create or update resources. Basic structure, here's the standard. A highball, AI generated. We're detoxing, man. Get out of here. Tech. If we get really desperate, we'll go back. So forgive me if this is a stupid question. I'm not very experienced with web programming. I'm implementing the payment component of my the component interacts with the external payment service. The payment service accepts HTTP post from. Okay. Generate HTTP post request from a controller. That's not what we need. Yeah, how to use. Making a game. We are not making a game. We are creating a very simple POC. We're creating a very simple POC as part of like a little challenge, little assessment. We're going over our C# fundamentals. We're going over a few concepts. All of the things in the description are relevant to that. But I'm just doing this as sort of a detox from AI / good fundamental learning thing. I honestly can't even think right now. I'm loopy. It's late, and we're gonna continue though because this is like due Wednesday. So let's continue. How to use HTTP post, HTTP get in ASP.NET Core. So, hi, I'm trying to build my app with Web API, but I don't understand how it works. I read the Microsoft Learn, but couldn't figure it out, and I can't run my project. So, values controller.cs, you set up the route, API/controller. So, let's see if we did that. Okay, so we set that up, so it looks like it's just only going to be hit from that. Public class values class controller place. Okay, so we did that. HTTP post. So we got the route. What is the root for? Public string. Then we added it. Blah blah blah. So Vine pattern URL swaggers HSS though. Okay, let's maybe research that. The values controls as below. Okay, let's analyze these rests. Oh, flash bang, man, bliksem. So, rest, that's... Oh, this is just normal paradigm stuff. Okay, this isn't particularly what I'm looking for. Maybe it'll solve my problem. Okay, so the launch URL property in the launch specifies URL for the page you want to open. For example, we create a new blah blah blah, blah blah blah. After adding the values API, note we're running this application. The values are below. Issue get no. HTTP posts. Okay, that's fine. Okay, so I guess this can just be add. Whoops. Add booking, very similar. So we defined our route now. Public string, so this is going to be a public, I don't know what result it's going to be. What is our action result? Let's take a look at that. It's foundational interface in ASP.NET Core. Uses a controller action return type. It finds a contract for returning HTTP responses, reduces and blah blah blah. Example, okay, bad request, okay. So basically return okay. Law. Hi Bo, we used AI. This is so dumb. I wish there was a way you could like disable AI in Google. Okay, so we've got our basic HTTP post add booking. This needs to, I don't want any parameters quite yet because we don't know the type of what we're going to be adding. We don't know anything along those lines. So for now, let's just do the basic things. We do add booking. We're going to be update booking. Update booking. We're probably going to have like a booking ID here or something just to track the booking, but we will get there eventually. We'll get there eventually. Ugh. Okay, let's continue. So we've got our add booking. So let's look at the requirements again, right? So in our POC, we need to be able to add a booking, which we just defined. We need to be able to edit a booking, which is update. And we need to be able to delete a booking. So let's do that. Let's do that. And let's do delete booking. Very simple. Let's also maybe do an HTTP GET. Very simple. And then for the HTTP GET, I don't even think we need this. Why are you causing an issue? Delete booking, update. Here. This is called get booking. Cool. Okay, so I think this is a very basic structure for how we can get this to work. Let's see if we can do the right one for an HTTP GET. Let's see if we can find an example. Nope, not what we're looking for. Okay, so this is just simply a HTTP GET. I think that makes the most sense. So HTTP GET, and then we'll pass an ID through. But screw get in ID. We'll do very basic stuff. This is just going to be a simple GET. Let's make it a GET booking. Nice and simple. Da 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 na 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 na. I actually don't like this, but I copied and pasted. Okay, let's get back into a little bit more of an explanation. HTTP GET, post, post, post. Okay, so this is I'm happy with this structure for our thing. So let me pull this a little bit nicer so some of you that's on the mobile view can see nicely. So what we did is we now defined a booking controller class, right? With this namespace here, this namespace. We defined that it's an API controller. We defined the basic route. We have an access modifier for the class, this booking controller, and it's extended by the controller base, which is C# boilerplate. We have a private read-only logging thing. So maybe we can even do a bit of a log here. I will research how logging stuff is done maybe tomorrow. And then tomorrow, this was a very, very, very basic just setup of the basic project structure. This is a very basic setup of basically the overall stuff that we need to do. But I'm happy with this so far as like a way back into AI, I guess. Let's take a look. Okay, so for the purposes of this application, the requirements, you are part of a backend engineering team, and the requirement is for a basic solution that allows someone to add a booking, edit a booking, and delete a booking. We did add, we did edit, we did delete a booking, and we also did a HTTP GET because, you know, why not? We want to show our full crowd. So the next thing we're going to need to do is we're going to need to define a service, basically a way for us to interact with the other services. Now, the proper way to do this is to set up something called an interface. And that interface is basically going to be a abstract class with abstract methods where we have the name of the methods, the parameters of the methods, and what is defined. And yeah, we're not going to define any implementation. So let's do a little bit of research on how to do that. And then what we'll do a little bit later down the line is when we define our types and stuff, we will add it and we will update as we go. So let's research so step one is how to set up an interface. or the standards at the very least. Okay, let's look. An interface is a completely abstract class which only contain abstract methods and properties with empty bodies. So interface animal, we have void animal sound, run, blah, blah, blah. Interface animal, void animal sound, and then pig implements it. That's fine. Yeah, I'm happy with this. So let's find out the proper way to create an interface. I'm assuming C# has boilerplate. So let's go to controllers. Let's go to our services, and then we're going to add a class. I'm going to add an interface. Okay, this is just going to be very simply a booking service. And it is going to be a normal class as well. I'm not doing this properly. This is just going to be a booking service class. Cool. Okay, so now let's look here at how exactly this is going to work. What I want to be able to do now is I want to look at my booking service, and I want to look at my actual service, and I want to look at the documentation. So what does the documentation say? We define an interface now. Now I need to be able to extend something, right? So this pig is now extended by iAnimal. So if I want to do that, I need to copy this interface. I need to go to our booking service and do that. That was ridiculously easy. Just sounded like Mike Tyson over there, damn. Okay, so let's do this. No. Okay, so cool. Let's go to our booking service and define the different interfaces that we're going to need for this particular project. So we've got void. So obviously it's going to have the type. I think this is the return type of this function. So let's go to our controller. We'll open up our controller just like that. And we're going to copy the modifiers. No, we're going to copy these up until here, and we're going to get that. So we got the HTTP get, and then we got the other action result stuff. So let's copy all of this to our iBooking service. We'll paste, and then we'll just strip what we don't need. So we're going to strip all of this up until there, just like that. And that's what we're looking for. So we're going to do this. Whoops, I made a whoopsie. This. And then we're going to... I wish there was a way you could, like, delete multiple things at the same time. Like, in Visual Studio, you were able to just... like Control D, and then we'd delete a whole bunch of these at the same time. Let me just read. Yo, Manto Talks. Welcome. You're officially a degenerate. Watching a programming tutorial like at midnight. What's going on here, man? I'm assuming you guys are not in my time zone. Where y'all from? Bros, locked the fuck in. Yeah, boy. Let's go. What time zone you all in? Because it's late where I am at. It's after midnight. From Bangladesh. Bangladesh, it's even later than now. It's like, is it minus +2? What time is it for you now? It's 4 out. It's 4 here. Is it 4 p.m. there? Like 4 p.m. or 4 a.m.? I assume if we're plus, it must be 4 a.m. there, bro. Shout out from Bangladesh. Damn. I hate our coding just isn't just put a 3-inch block on its platform. Instead, its public interface does not implement. GMT +6 4 a.m. Yeah. Damn. Okay. So first things first, why are you awake at 4 a.m.? Number one, like it's like Wednesday, right? No, it's Tuesday. 4 a.m. on a Tuesday. What's wrong with you? Go to bed. Vex, how you doing? So if you understand the programming fundamentals, boilerplate like public interface isn't a hectic thing. It's more descriptive than your block stuff. So I learned how to program actually on something called Scratch, and that is literally like a block drag and drop. Yeah, that is literally a block drag and drop, and I learned a lot from that. Like I programmed, if you guys remember the game Plants vs Zombies, I literally made that when I was like 16. I didn't make Plants vs Zombies itself, but I made a recreation. I called it Teachers versus Students, and like the nerds produced homework, and like you click on the homework, you collect it, and it was grid layout. It was actually pretty cool. I hope I could have the late night movie and found a caveman coding on a cave laptop and decided to gain some elite ball knowledge, man. Yeah. I'm sorry, my messages doesn't make sense. I just took some words from your screen. Don't worry, Vex. Don't worry, Vex. I got you. I'm tired, bro. I'm tired. I've been programming. But yeah, I'm glad you like my thumbnail. Thumbnail's not AI generated. That is my setup. I pinky promise, bro. I'm winking there. You can see me wink. Okay, let's get locked in again, right? So we defined our booking service. We defined our normal hypo. Okay, so it's going an area because we defined methods here, right here, that we now didn't implement. So if we look back in our documentation, we literally need to go back to our controller. We need to copy all of this again. And then we need to go back to our service. And we need to, one of these. Then we're going to delete all of this, all of this, all of this, all of this. We now need to find out why you break. How about just return? Why are you breaking? Show potential fixes. I don't know why this breaks. Hold up. Interesting stuff. I'm getting old, bro. I have a question. Why do you have 2 live streams? Okay, so when you shout out to whoever subscribed, lots of kisses. So on YouTube, or on Streamlabs, you have an option to do a portrait view that shows up when you do like YouTube shorts. So when you scroll normally, that's the portrait view that locks up. And I've got a normal view where you see like my entire screen. And the way I think it works is if you click on that little arrow at the bottom of your YouTube shorts, it hoys you to this one. But a majority of my views do come from the YouTube shorts, and a lot of my subscribers only have phones. So it's not like they can easily watch on a computer or watch on a phone. Like a lot of the people in our Discord only have phones. So yeah. By the way, Discord, join the Discord. Normally I don't stream programming. Normally I play like Minecraft and Arc Raiders, and I game and I talk nonsense. But if you guys want to be a part of events and stuff, like join the Discord. I want to do like a Minecraft Skyblock thing, and in order to do that I need like cool people. So make sure to join. Hello. Yo, I'm a lean in. Rekan Ramadan. Ramadan was on Saturday. You're late, bro. I should make a Roblox game. I suppose I'm probably able to make a Roblox game. I have enough programming experience. Like I wouldn't doubt. I don't know how difficult it is to make a Roblox game. That could maybe be an interesting stream. I've never been into game dev. Actually, I'm talking rubbish. I used to watch a YouTuber that was like only into like Unity, but Unity is programmed with C Sharp, and this is literally C Sharp that I'm doing now in the video. So that would be maybe kind of cool. Okay, so let's figure out why this is throwing. The name OK doesn't exist in the current context, but here it does. So maybe I can just return. Does it need to be of type action result? Would that need to be public? I wonder. Okay, so what I'm doing now is I'm actually doing like a very realistic Steeler Brain Rot V2. Yeah, it's rough, bro. Okay, so what we're doing now is we're actually taking a look at documentation. We're doing a bit of a detox on AI. So when we program, I want to like understand the problem. I want to research how to solve the problem. And we come up with a lacquer solution there. But in order to do that, I need to like actually read documentation. So let's firstly understand what iAction results is. So what is iAction results? And what does a successful return type look like? The most basic action returns a primitive or complex data type, for example, string or a caption object. Okay, so return I enumerable T or async. So see this. It buffers the result of actions that return that before writing to them in the response. Consider. Okay, so an I enumerable is basically like a task or a list of lists. Consider the following action. So it's basically a response that you can iterate through into the front end. That is interesting. So the action result type is an appropriate when multiple action result return times are possible in an action. The action result is a various HTTP station codes and a non-abstract class deriving the action result called for a return type. Some common types are the bad request, the not found, and the OK object result. Alternatively, convenience methods in the controller base class can be used to return action result types from an action. For example, return bad request is a shorthand form of return bad request action result. Because there are multiple return types of paths to action, the liberal use of the prior response type, blah, blah, blah. Okay, so this is literally what we're looking for, right? I don't know what these are called. Route response types, I guess. Okay, so I guess we can copy something like that. We can go to our controller and then we can say, okay, produces and then void. That makes sense. This would obviously just be a standard success. This would be a standard success. This would be a standard success. So these are now fully done. We don't need anything like that. The HTTP GET obviously needs that. And when we define our type later, we'll just add it to that. But we also need to specify that it's not found. So maybe what we'll do... This also gives us a good example on how to define our thing. So let's do something like this. We'll say var, we're declaring a variable booking is equal to product context.id. Let's just make it null for now, I guess. Or 0. And we'll leave a comment here that says to do. Appropriate call to backend. Service. Okay, so we're doing good. Why can't I do that? Okay, I guess this is fine. Okay, so anyway, back to this. So actually all of these need to be asynchronous. I wonder what this does. We'll take that. I'll take all of this. Media type names.application.json. I'm just actually going to change it to BRB. back in business, baby. We're back in business. Okay, let's continue. Okay, we're reading documentation. It doesn't look nice. This is nice. I'm happy with this. Hmm. 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 Alright. Let's get some music going. Get some music going. Yo, man, chow by mosquitoes here, bro. Nah. They're looking at me and they're like, you're so sweet, man.
Let me tell you something about Phonium. Yes, it's the rent-a-new smartphone Phonium. But for me, Phonium is where I get to save Imalium, aka Cashium. Why? Because for a smaller price per month, I get a smartphone yam, insurance yam, and connection yam. To think all it takes is visiting Ackermans, Pep, or phoneyam.co.za. T's and C's apply. You should also apply. Now, quick, simple, connected.
Phonium.
Yeah, I had to Google the shortcuts now, Zaystine, but we're getting better, we're getting better. How's the music, by the way? Can you hear it nicely? I am my breath, you held your tongue. It's been so long. It's so long, Put your music suggestions in chat, I'll play it for you. I cannot be responsible for maintaining the DJ of this channel, man. Come on. Turn me on. Like a spot just like you on it. Na 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 na. Yeah. I held my breath, you held your tongue. What's wrong with this? Bible. I guess. A song on beat, but I got no. Let's analyze. Where did the time go when nobody wastes time like me? Where did my mind go when nobody come limelight pit? Pour out all the time, I think I've been alive. I ain't lost my mind.